A good day to everyone. I'm honored to present at the Design Principles and Practices Conference. Today, I'll be discussing a co-design framework we have been developing at the intersection of systems design and artificial intelligence. Our talk is titled Co-Designing with AI, where we leverage generative AI to transform games into industry-specific simulations. As a postdoctoral fellow at MIT, my expertise lies in the intersection of systems design, manufacturing, and supply chains. My research focuses on industrial resilience, which is about solving supply chain issues in factories. Leveraging human AI machine collaboration, I build recommendation systems to help companies detect and recover from disruptions without replacing their existing technology stack. At the same time, I would also like to take the chance to acknowledge my colleague, Dr. April from Singapore, and my students from MIT for their contributions. Simulations are important for businesses to anticipate and plan their workflows efficiently, allowing organizations to remain robust in today's business landscape. As such, we are undergoing a major shift in design paradigms, moving away from traditional silo-based approaches towards human-centric resilient systems. While the latter focuses on mechanistic efficiency and static optimization, which are effective in stable environments, they only capture current lived experiences and do not account for long-term systemic evolution. So to bridge this gap between present actions and future readiness, we propose a future-ready synthesis driven by agentic AI to shift towards the human-centric resilient systems. The primary challenge here is what we call the temporal gap. Traditionally, developing customized simulations for complex systems is a slow, expensive, and rigid process, resulting in a critical lag. Furthermore, the dynamicity and the pace of black swan events make it difficult to adopt off-the-shelf tools promptly as a decision support tool, resulting in operational disruptions. As such, organizations struggle because their tools are anchored in the present, leaving them unable to effectively anticipate systemic shifts. So this brings us to the significance of our work for Industry 5.0. We are looking at three key contributions here. The first is about temporal resilience, building systems that adapt and evolve through anticipatory modeling rather than just withstanding shocks. The second is about agentic AI speed. Using Gen AI, we can generate complex simulations in hours instead of months. So the final one is about human centricity, where using simulations as cognitive scaffolds, we can align system behavior with mental models of human practitioners. To address this, we developed the code framework, which serves as an architectural scaffold for simulation timing and state management. CODE code stands for Create, where we define learning goals and deconstruct the existing mechanics. Orchestrate, using AI to scaffold code structures and logic. Deploy, integrating components and testing the simulation. And Expand, where we adapt variables for specific industry contexts and scale the model. So a key part of this methodology is the zero-shot prompt engineering approach and the integration of agentic AI. Instead of manual coding, we use a prompt-based approach that captures system anatomy holistically to instantly generate functional prototypes. Using our zero-shot prompt engineering structure, we achieve better replicability with minimal hallucinations. Starting with the intent layer, we first map out the objectives of the simulator and use a role-playing approach to ensure that the generative AI can effectively capture the industry or company context. Next, in the logic layer, it contains specific organizational constraints, logics, data inputs, and workflows. Lastly, the output is specified, comprising typically of user experience flows, presentation style, and decision support outcomes. So here, Agentic AI introduces new capabilities to the simulation domain by enabling players and system entities to be configured within specific behavioral profiles. Here we present a structured approach to creating such agents. So this process begins by defining agent personas and operational constraints, followed by specifying the data sources required for decision making and reasoning. So there is also a game master layer who then orchestrates the simulation by triggering agent responses and updating system states across each round. So by integrating large language models as active simulation participants, the system achieves greater dynamism, behavioral diversity, and realism. So this results in simulations that are more accurate or more accurately reflect real-world conditions. So to test this out, we first recreated the beer game before adapting it for two very different high-pressure sectors to demonstrate its versatility. The beer game is a supply chain simulation where participants manage inventory and ordering across various roles. So it demonstrates how delays and limited information can amplify demand fluctuations upstream, creating these inefficiencies known as the bullwhip effect. As supply chains vary greatly across each sector, we selected the following industries. First is the semiconductor industry, where we modeled after companies such as NVIDIA with its complex fabrication cycles, capacity constraints, and more. Next is the fast food sector, where it resembles cold chain logistics with regional consolidation, rapid demand fluctuations, and more. So these frameworks successfully reflected these sector-specific delays, thus validating its versatility. So during our workshop, we moved from basic replication to advanced customization. On day one, participants executed the classic beer game to establish a baseline for information flow. So this process includes experiencing and understanding the beer game mechanics and recreating the game in various modes, such as multiplayer, role-based single player, and agent-only simulation. So here, a functional simulation of the beer game is created. So to help participants better understand the different roles in the beer game, prompt cards containing tips were provided to help them understand and recreate the game mechanics. Subsequently, this knowledge also ensured that even those without supply chain expertise could contribute to the simulation design. Here are some examples of participant-made outcomes detailing the mode of play, current status, inventory tracking, and disruption impact. So the game mechanics were tested and verified through repeated gameplay. In day two, participants used the zero-shot prompt engineering and integrated agentic AI again to demonstrate AI friendliness in adapting the beer game for industry-specific contexts. So to adapt the beer game mechanics for specific industries, we leverage ontologies to derive relevant outcomes with minimal hallucination. So the chain of thought also sheds light on the system-generated considerations, allowing participants to derive insights from the simulation's reasoning capabilities. So for the semiconductor industries, participants modeled the simulation after NVIDIA. Taking on the role of the designer, participants then enhance the layout and customize the gameplay mechanics with AI-assisted co-design to improve user experience. So this includes adding supplier capacity constraints, additional product offerings, key performance indicators, and more. Similarly, in the fast food industry, participants modeled the simulation after Martin Bauer, supplying McDonald's outlets within the target region. So industry-specific complexity and requirements which are distinct from the semiconductor, such as information and material flow, can be distinguished from the participant's output. So here, using our proposed zero-shot prompt engineering approach, we can generate simulations in hours that would normally take months. So this rapid prototyping mechanism effectively democratizes access to planning tools and decision support systems for organizations. At the same time, dynamic scenarios such as demand spikes and supply disruptions can be realistically simulated to better analyze the feasibility of mitigation efforts. So beyond speed, these simulations also act as cognitive scaffolds. So they help externalize the tacit knowledge of experts, making their implicit assumptions visible and testable. This strengthens the user causal understanding of dynamic scenarios by analyzing agent behavior, which is vital for judgment under future uncertainty. So the real shift here is moving from automation to AI-assisted co-creation. So here, AI serves as a collaborative partner to help designers explore and develop dynamic solutions that were previously too tedious or expensive to model manually. At the same time, limitations of this proposed approach come in three main points. Firstly, the simulation's quality is tied to the reasoning capabilities of underlying large language models, and furthermore, the generated persona will still require validation by human experts to ensure accuracy. And lastly, we must also remain vigilant about AI models inadvertently reproducing historical biases. Looking ahead, we plan to further develop co-design with AI in the following areas. So this includes expanding the code framework into critical industry sectors such as healthcare and aerospace, which are vulnerable to supply disruptions. Next, the integration of real-time data to create digital twins can better represent the current context, allowing faster disruption response. In conclusion, co-design with AI is designed to transform industrial simulations to be human-centric decision support systems. The proposed code framework transforms simulations from static models into dynamic instruments for training and temporal resilience. So by embracing collaborative intelligence, we can better design for a resilient future. Before we end off, here is the list of references highlighted in earlier sections. It details the background information as well as state-of-the-art developments in their respective domains. We have reached the end of the presentation. Thank you for your time. And if you have any questions, do put them in the comments below.